Hello everyone. I wanted to start off today by introducing you to my son, Tomer. This is Tomer. He is 5 years old, and he really likes to build, especially with Legos. So time to time, Tomer asks me to play Lego with him. So one day, I take a specific Lego set, and we start to play. Tomer is very creative. He immediately starts to build a huge tower. But as you can see here, the number of the pieces are limited over here. And Tomer, he starts to take some other pieces from other Lego sets we have at home. He starts to mix everything together and build his own tower. Everything is fine and good up until he takes one incompatible piece with the top block of the tower he built. He tried to match them together. He pushes too hard, and unfortunately, everything collapses. In large-scale projects, we may face the same problem. One incompatible dependency can also break everything. And this is the main reason it really reminds me playing Lego with my son. I want to introduce myself. My name is Avi Youkhananov. I am a backend guild master and a staff engineer as part of DevX team, Development Experience team. I will say a bit more about this team in a minute, but in general, we focus on the application infrastructure in Outbrain. And today, I'd like to share with you a problem we encountered with dependencies when we start to share libraries among repositories. We will see why sharing dependencies among repositories can cause us in issues and turn into dependency hell really quickly. I will lay out to some ideas and solutions we developed in order to tame this problem. But first, some background. But before we'll deep dive into the architecture part, I'd like to say a few words about Outbrain. Outbrain is the world-leading recommendation platform for the open web. We have 600 services, 1,000 employees, and 344 billion monthly recommendations, and this number growing on a daily basis. And of course, we have an exclusive partnerships with many publishers like CNN, MSN, Fox News, and etc. So let's go back to DevX team. When I was looking for a good definition of DevX team, Development Experience team, I couldn't find something that truly fit to what is DevX's goal in Outbrain. So I decided to give my definition of DevX's goal in Outbrain, and believe me, I also tried ChatGPT. So DevX's goal is to make the developer experience or life to be a bit better by providing the best tools to build the best product. And all of this in a supportive way. Few years ago, we moved from one big monolith to the microservice architecture. And as you can see here, this is a service traffic map that is presented as part of a tool that's called Visceral. Visceral developed and open sourced by Netflix, and we in DevX team, we decided that we are going to enhance this tool in order to give better visibility about our traffic for our teams. And of course, as part of this decision, we also moved from one big monorepo to the multi-repo approach, to a small unit of work. Every team has its own repository, and every repository contains the same structure. It contains two main modules, the services and the libraries. In Outbrain, sharing code is a known way of working. It's also a best practice in order to avoid code duplication. So if one team writes a code, he can expose it in a library form that other teams can just use it. Actually, it's not only best practice of Outbrain, many other companies adopted this approach, and we are as well. So as I mentioned before, we work in a microservice architecture. And in order to communicate between services, we use the client libraries. Every team responsible on a certain number of services, and the teams also write the client code. So it makes sense, because the team familiar with the API, they know if metrics, logging, other mechanisms should be part of the library or not. So I'm not talking about a thin layer of a code, a thin layer of a library that contains only the API and data transfers objects. It, of course, may contain the API. It can have some logic over there. It can use some shared code, logging, caching mechanism, metrics, and client load balancing. Yeah, we do have client load balancing, and other mechanisms as well. So now the most interesting part, how we define dependencies in Outbrain. So let's assume we have Outbrain service, let's call it OB service, that wants to communicate with service A, wants to use some code from team B and get some Guava capabilities. So we will define client A within a specific version. We will define library B within a specific version. So as you can see immediately, we have different versions for different teams. And Guava, in our case, Guava 21. But as you can see, again immediately, that we have two types of dependencies that we are managing, our internal libraries and the external libraries, the third-party dependencies. And if you will count the number of dependencies that we defined, we will count 3 dependencies. It's obvious, right? But if we will take a look from a different angle, and we will take a look on the dependency tree graph, we'll see that currently we have 2 additional dependencies. So the main question here is, what are those dependencies and where are they coming from, right? So our libraries, bringing with them their own set of dependencies, which called the transitive dependencies. And moreover, the transitive dependencies themselves can bring other transitive dependencies, and the others can bring others, like friend that brings a friend, and etc. And the build tool that we are using, Maven, Gradle, Bazel, will download each and every dependency that is needed to run our library. But now the main question, what Guava version will be in use? But why do we need only one Guava version to be used in runtime, right? So the main reason is the JVM and how it works. It's all related to the Java class path and the class loader. When the class loader loads the classes from the Java class path, it loads each and every class only once. So the build tool says, I need only one version of a jar as part of my class path. And this situation called the conflict resolution. So we use Maven in Outbrain. And Maven says, I have a conflict. OK, and the conflict resolution strategy in Maven says, pick the nearest in the tree, and it would be Guava 21 in level 1. For instance, Gradle build tool has different conflict resolution strategy, and he kind of understands versioning. He will pick the highest version of a specific dependency. OK, so what can happen in runtime? Let's take a look on a real use case. Actually, we had this use case, exactly this. As we can understand, Guava 21 loads into the runtime, but as you can see, client A still uses a method that's called object first on now. This method in purple that exists in Guava 18. But this exact method does not exist anymore in Guava 21. And if you are asking why, because it was deleted. Actually, it was moved from objects class to more objects, so it does not exist anymore. And the question why, you need to ask Guava team, of course. OK, and if client A will try to call this method in runtime, we will get one of the following exceptions. No such method error, no such field error, no class def found error. And believe me, these kind of exceptions are really evil. How many of you familiar with this kind of exception got them during runtime? Oh my God. OK, it's great that you are here. And I can tell you that you are not alone. It impacts every engineer in Outbrain. And even us, the infrastructure team, we got tons of these problems. And moreover, I can tell you that when I Googled Guava compatibility, I got more than 2 million results. It's insane. And we are talking about only one dependency that can cause compatibility issue. And as you can understand, there are many other dependencies that can cause compatibility issues. And as part of our projects, we may use tens of them, hundreds of them. So it came across our table of DevX team, and we decided that it's a time to do something about it. We must do something about it. And one of the solutions that we selected and turned out as a good approach is pinning versions. So pinning version means that I don't care about any conflict resolution the build tool has. Instead, the version that I will define, this is the version that will be picked by the build tool. For example, in Maven, you can define all your dependencies as part of the dependency management section. In Gradle, you can use force. However, we are working in a microservice architecture. And in order to maintain these pinned versions across multi-repo, it generates a lot of tech debt. Moreover, if you want to update specific pinned versions across multi-repo, it involves a lot of user interaction. You need to create a pull request to the relevant repositories. You need to get at least one approval. You need to merge it. And then, after the merge, you need to deploy all the affected services. So we wanted to keep this pinning versions approach, so we came with an idea. So why not to have a centralized dependency management? So it means that we'll define all our dependencies in one place, in a centralized place. I mean all of them. All the dependency that is required by our services. And the services will just use it. It's problem solved, right? Not yet. So actually, we changed a bit how repos look. From a multi-repo approach, we went to the hybrid approach. We added a central repo that currently contains our dependency management section. All our dependencies is part of it. And as part of this decision, we also moved all our libraries to sit together in the central repo with the dependency management. So now, the big advantage of this approach is that currently we manage only one version for the dependency management and the libraries, instead of different versions for every team. So let's go back and see how we do, to Obi service and see how we define our dependencies today. And as we can see immediately, Obi service inherits from a parent that called central pom, that actually pointing to the centralized dependency management within a specific version. And this version also defines all our internal libraries versions. So when we will define our internal libraries like client A or library B, we don't need to specify the version anymore because it's already defined as part of the centralized dependency management. And the version is 500. But moreover, when we will define our third-party dependency like Guava, we don't need to specify the version anymore because it's already defined in the centralized dependency management. So we have only declaration over here. Only place is the centralized dependency management. And if you're wondering, this is how the file looks like. It's a big file that contains all the required dependencies. And now, the most interesting part is how we automate upgrading dependencies. We'll focus on the minor version upgrades because this process we managed to automate. So let's take a look on how we do it. So version Maven plugin is the plugin that helps us to upgrade all minor versions. So let's go through the process and see how it works. So we run the version Maven plugin. With all these upgrades, we create a pull request. Then we want to make sure that all the gatekeepers pass. For example, we have many gatekeepers. One of them is if the build pass, right? And then we merge and release a new version. And this is something that happens every week. Now I'd like to go over some gatekeepers we use in order to avoid common mistakes in our monorepo, in the central repo. We'll go over some tools we build and rules we use in order to avoid common mistakes. So first, we want to make sure that all our repositories updated with the latest version on a regular basis. So we build bumper tool. Bumper tool can be triggered as part of the automatic process and can also triggered manually. So we'll go over to both processes. Every Monday, we get the latest version of the central repo. Then we send a pull request with the latest version to the repository owners. So let's assume that our latest version is 502. This version may contain some changes in the dependency management and some library code changes. So we are getting upgrades. And every Wednesday, we merge all these pull requests. And now, I might shock you a bit. We merge all these pull requests even if the build fails. So now you might be wondering, how many builds failed, right? So I came prepared. Actually, I updated this slide 2 days ago. And as you can see immediately, this visualization shows us that the build success rate is higher than 90% for all the cases, for all the last 8 bumps, which is actually 2 months of bumps. And moreover, teams can always go back and use the previous version. They just need to make sure the version they use is not older than 30 days. Otherwise, their build will fail again. So another example, we can trigger bumper also manually. For example, in critical API changes, when teams want to make sure that the consumer of their libraries using the latest version, using the latest API. Another example is the log4shell issue. I assume that all of you are familiar with the log4shell issue, right? Okay, cool. So as I mentioned before, we had almost 100 repositories, and we were required to upgrade all of them. And we managed with Bumper to update all the repositories with less than a few minutes. We just triggered Bumper, and he did all the work. The second gatekeeper is the Maven Enforcement plugin. Maven Enforcement plugin is the plugin that comes with a set of built-in rules that we use in order to prevent common mistakes. The big advantage of this plugin is that you can write your own custom rules and use it as part of your build. So we use many rules, but today we'll go over 2 of them that from my perspective, they are most important, ensuring compatibility. So rule number 1 is the ban dependencies. And it really helps us when we upgrade major versions. It really helps us to get rid from old implementation from an entire dependency. For example, when we upgraded log4j to log4j2, when we upgraded JUnit 4 to JUnit 5, we wanted to get rid from JUnit 4, for example, because it's not relevant anymore. The rule number 2 is the upper bound rule. And this rule really helps us with transitive dependencies. And it means that the dependency version resolved during a build is equal to or higher than all the transitive dependencies that we are getting. It makes sure API stability for all the consumers of our libraries. It makes sure breaking changes. It makes sure that we will not have any breaking changes over there. So now you might be wondering, what if the upper bound breaks a lower version? For example, Hadoop and Spark that contain old Guava version. Who is using here Hadoop and Spark? Okay, at least you. So you might be familiar with this kind of problem. And we actually cannot exclude it. We have some situation that we must using this old Guava version or old dependency. So one of the solutions is shading. So first of all, what is shading? Shading is reallocating classes. So you just give a unique package name, and as a result, there will be no conflict anymore. So now you might be saying, it's a great solution, right? So it's a good solution, I agree, but you need to be aware that shading comes with pitfalls. For example, netjar, it comes with a static pool buffers that are allocating memory. And if your application or your class path will contain the shaded jar and non-shaded jar, your application will start to suffer from memory issues. If you have JNI code, you need to make sure that the JNI code is reallocated as well. And there are more pitfalls, like debugging into IntelliJ. So all in all, I started with my son, Tomer. And I eventually figured out that we can combine multiple Lego sets without making the tower to collapse, with the right control, with the right monitoring. And we in Outbrain, we struck a balance between managing thousands of third-party dependencies and hundreds of internal libraries and maintaining compatibility among them. And we in Outbrain, we really recommend you to find your balance with dependency too. And if you're not familiar, this is the widget of Outbrain. Thank you very much. You can reach me via LinkedIn or read my blog posts.